Okay, today we're going to talk about exponential equations with variables on both sides. Now, we've already talked about equations that have variables on both sides, but equations that we've spoken about before have bases that could be made the same. But here in example 1, you can see there is no way I can get a base of 5 and a base of 8 to be the same. So the only thing I can do in this case is to take the log of both sides. So if I have some base raised to some exponent equals some base raised to some exponent, then I can take the log of both sides. I'm going to choose to use the common log, which is base 10, because eventually I'm going to actually put this in my calculator. But you could use any log base you wanted to. So I have the log base 10 of 5 to the x equals log base 10 of 8 raised to the x minus 4. The next step on this is to bring your exponents down in front. So this x becomes x log 5, and this x minus 4 will come in front of the log of 8, remembering to put it in parentheses. Because this x minus 4 is in front of the log, and that's really important to note that it is in front of the log, I can then distribute this into the log. So I have x log 5 equals x log 8 minus 4 log 8. Please note that this is in front of the log. There will be times in the next lessons that we do where you might have some parentheses behind the log, and then you simply cannot distribute. So please make sure you're only distributing when the parentheses is in front of the log. Now I have x on the left side of the equation, but I also have x on the right side of the equation. So what I want to do is I want to gather all the terms that have x in it on one side of the equation. So I'm actually going to add 4 log 8 to one side and then subtract x log 5 because I prefer to keep as many of the terms positive as possible. Now on the right side of the equation, I have 2 terms that have an x in it. So the only way I can extract that x out to solve for it is to factor an x out. So if I factor an x out of the right side, I have x, parentheses, log 8 minus log 5. Remember, this log 8 minus log 5 is really just a number. So I can go ahead and divide both sides of the equation by this log 8 minus log 5, and I'll have solved for x. At this point, you can go ahead and put this right into your calculator to get an answer. Your answer will be a decimal, and you'll round to whatever I say, usually three places. But please remember, if you're putting it into your equation, into your calculator just like this, if you have more than one term in your numerator or more than one term in your denominator, you'll have to use parentheses when putting this in your calculator. If you don't want to use parentheses, you could also go ahead and condense this and make your denominator log 8 divided by 5, and that would be okay too. So the answer to this would be 17.697. It would be a good idea to pause the video now and try putting this into your calculator to make sure you get the right decimals. Very often it is not solving these equations that students have problems with, it's putting them into their calculator. All right, so if you want to kind of take some notes on the steps that you'll have to do to solve these, the first thing you're going to do is take the logs of both sides of the equation. You'll expand them, which means you're just going to bring any exponents down out in front of the log. Distribute if the parentheses is in front of the log. Gather all the x terms on one side of the equation. Factor out the x. And then solve for it, which is usually dividing by some number, and then put it into your calculator. All right, here's another example. Why don't you pause the video and try this one on your own? Did you get x equals 0.884? Let's take a look at the steps. Take the log of both sides, bring the exponents down, putting them in parentheses on the right side if there's more than one term. Distribute since the parentheses are in front of the log. Gather all the x's on one side of the equation. Factor out the x and divide to solve for x. Again, if you prefer to condense these logs to make it a little easier to put in your calculator, go ahead. Remember, this 2 here can go up to the 3 as an exponent, so it can become the log of 3 squared or the log of 9. And in the denominator, subtraction turns to division, so it would be the log of 36 divided by 3, which is the log of 12. All right, pause the video and see if you can do this one. Did you get x equals 0.488? Right. Take the log of both sides, and in this step I also brought the exponents down all in one step. Distribute the parentheses since it is in front of the log. Gather all the x terms on one side of the log. Factor out the x and divide to solve for x. Try this one. 13.627. This one's a little different because you have two things now on this side of the equation. So what you'll have to do first is you'll have to expand this log. So I expanded the log, and at the same time I put the x down in front of the log of 5. I remembered to put parentheses in front of the log of 7 since there's more than one item here in the exponent. Distribute the x minus 2 since it is in front of the log. Gather all the x terms on one side of the equation. Factor out the x and divide to solve for the log. To solve for x, I'm sorry. Again, if you prefer to condense the log before you put it into calculator, that would be fine. So you could have the log of 98 over the log of 7 over 5. And that's all there is to it. If you have questions, please let me know.